Hi, this is Scott Howard with Buyer Security. In this video, I'd like to have a brief discussion of the major features and benefits of the Tofino OPC Enforcer module, and then we'll go through a sample configuration session with this module. Quick review on the Tofino industrial security solution. All of the security features of this product are embodied in a series of firmware modules called loadable security modules. Basically, the product ships from the factory without any modules installed, and at installation time we can choose which modules we want to deploy in each of the security zones in our control network. There's a series of modules available. New modules are being released on a regular basis. Today the module we're looking at, the OPC Enforcer module, is designed to perform content inspection and protection of OPC servers. Quick background on OPC. OPC is an industry standard mechanism for sharing data between multi-vendor systems. It's based on top of the Microsoft DCOM API. DCOM stands for Distributed Common Object Model, and this is a programming interface that was developed by Microsoft to allow PCs to share data easily over a network connection. Let's look at how that is done from a network and a firewall perspective. First of all, let's look at how most conventional protocols work. Most protocols use a fixed, well-known port number on the server device, and anytime a client needs to access that service on the server, it always connects to that same well-known port number. For example, in Modbus TCP, every Modbus TCP slave device makes that service available on TCP port number 502. And when a client device wants to connect to it, it always connects to port 502. From a firewall perspective, it's fairly simple to protect that Modbus slave, because we can simply configure a firewall rule that allows traffic between these two devices using that destination port number 502. OPC and DCOM is a little different. Every data connection between an OPC client and a server is a two-step process. In the first step, the client connects to the OPC server on port number 135, and it asks the server, here's the object XYZ I'm looking for. Where can I find it? The server responds with a message that says something like, yeah, I have that object and you can access it on port number 12345. And that number, 12345, could be almost any port number. The second step is another second TCP connection that is created by the client back to the server on that new TCP port number that the server gave it on the first connection. And once that connection is established, the OPC client can read and write that data object to its heart's content. Now, the tricky part about this from a firewall perspective is that we have no way of knowing ahead of time what that port number will be for that second connection. In this example, it's 12345, but in fact, the way DCOM works, it could be basically any port number between 1024 and 65,535. A conventional firewall is basically not useful to protect an OPC server, because we don't know what port number will be used for these data connections, so we basically have to open all the ports between the client and server. And if we're opening that many ports, really, what's the point of using a firewall at all? And that's the main reason why OPC servers today usually run wide open with no firewall. So Tofino OPC Enforcer is the first security product that solves this problem in a way that's effective for the use on the plant floor. What we do is we use content inspection technology so that the OPC Enforcer module can listen in on that first connection request between the client and the server. First of all, as the connection is sent to the server, it takes a look at it and makes sure that it complies with the requirements of the OPC and DCOM specifications. And then when the server replies back to the client, it listens in on that, and it extracts from that message the port number that the server has assigned to the OPC data connection. It will then dynamically open that specific TCP port number in the Tofino firewall and keep all other unused ports closed between the OPC server and the rest of the network. So when that second data connection comes in to the server from the client, the Tofino is ready for it, and it already has dynamically created a firewall rule to permit that connection through, but it does not allow any other invalid or unauthorized connections to pass through that firewall. And so this makes Tofino OPC Enforcer the first practical tool that's available to provide firewall protection to OPC servers. This means that all those other unnecessary and potentially vulnerable ports, the thousands of ports and the hundreds that are used for many Windows network services, are not going to be open and potentially to be compromised by malware or other cybersecurity incidents. So let's go through a sample configuration session with the OPC Enforcer module. Our sample network looks a lot like the previous network we've used to demonstrate the firewall module. And in fact, like all other Enforcer modules, the OPC the OPC Enforcer does rely on the Tofino firewall to do its job. But our network here is a little different. We have two devices. OPC client is at IP address 1.21. OPC server is at IP address 1.22. And unlike our previous examples, both of these devices are Windows PCs. Pretty obvious those are the primary platforms for OPC. So what we want to do here is we want to protect that OPC server by inserting a Tofino in series between the server and the rest of the network. And of course, we are also going to connect another Windows PC, which will run the CMP software so that we can configure and test the Tofino appliance with OPC Enforcer. So let's go do that. I'm running an OPC server and client as virtual machines. The OPC server doesn't really have much visual going on because all of the action is taking place with the OPC services that are not graphical, so that we won't have to look at this OPC server screen too much. Here on the OPC client, I'm running the Matricon OPC Explorer as a client and connected to that OPC server at IP address 1.22. I'm just reading some random data from that OPC server, and you can see that the data is changing a couple times a second here. Just random numeric and string values that we're reading from that server. So you can see our OPC connection is up and running. Now I have inserted a Tofino security appliance in front of that OPC server. Let's go and configure it with Tofino CMP. All right, here's our CMP. Similar to the firewall example, we want to first of all build a model of our control network in the network editor in CMP. Then we want to set up our firewall rules and our OPC Enforcer to protect that server device. And then we'll test that configuration to make sure it's correct. And then finally we can deploy our Tofino into operational mode, where it will actually start enforcing the security rules that we put in place. So I want an icon in this network editor to represent both my OPC client and server devices as well as the Tofino. Let's start by adding an icon for the Tofino. I'm going to use the Tofino Discovery Scan feature in CMP to locate my Tofino security appliance. There's my Tofino security appliance. When the Tofino is discovered, it is presented in the Tofino Discovery view as an icon that I can simply drag from that view and drop into my network editor. Let's go ahead and do that. Now it's asking me to give the device a name. Let's call it Tofino to keep things simple. I could also enter the location of the device if I want. Because we used the Tofino Discovery feature, the Tofino ID for this device has already been pre-filled. Let's just finish that process. Do we want to change the Tofino to passive mode? Yes, we do. If you're not familiar with that feature or with the different modes of operation of the Tofino, please have a look at the first video in this series because we go through those items in detail. Now let's deploy our firewall and our OPC Enforcer modules on this Tofino appliance. So as I mentioned earlier, the OPC Enforcer, like all the other enforcers, does rely on the Tofino firewall module to do its job, so we must have that firewall module activated on the appliance in order to be able to use the OPC Enforcer. So let's go ahead and activate both those modules. Okay, they're both active now. Let's quickly review our network diagram. We have an OPC client upstream of the Tofino at IP address 1.21. Our OPC server is downstream of the Tofino. It's connected to the trusted interface and it has an IP address 1.22. So let's configure our network editor to match that physical network. First of all, we'll put an icon below the Tofino for the OPC server. We will give it the server address 192.168.1.22. Let's set up another icon upstream of the Tofino, and this will be for the OPC client. It has IP address 192.168.1.21. And we'll give it a second to update the network diagram. There it is. All right. Now, first of all, we need to create a basic firewall rule to permit the OPC connections to pass through the Tofino. This is a talker rule. So the way we create this is by, first of all, dragging the OPC client onto the talker rules list on the OPC server's firewall tab. When I drop that device there, it shows up under talker rules. I then want to locate a protocol in my protocol list called OPC Classic TCP. Let's drop that protocol on top of the OPC client on our talker rules list. Similar to the Modbus Enforcer, we now have a firewall rule that allows connections to pass through the firewall on TCP port 135, and that's the first of the two connections that are made for each OPC session. What we want to do is change that permission on that rule from a blanket allow to the enforcer permission, and what this does is it tells our Tofino that we need to be processing traffic on this firewall rule with the Tofino OPC Enforcer. When we do that, then this OPC client device becomes visible on our OPC Enforcer tab. This is where we can set options for this OPC connection, and there's only a few options that we need to set here because most of it's handled automatically by the OPC Enforcer. First of all, we have the ability to enable or disable sanity check. Now, some OPC clients do break the protocol rules and do not conform correctly to the requirements of the DCOM protocol specs. So some clients have to have sanity check turned off. Other clients also fragment their OPC requests across multiple DCOM packets. In that case, we must turn off the fragment check for those clients. And finally, we have a setting here called connection timeout. This relates to how long the hole in the Tofino firewall should be left open to enable that data connection to come through. We try and keep Tofino to be as secure as possible, and we don't. Once an OPC data connection is created, we don't leave that, or we would like to not leave that connection open forever. We'd like to leave it open only long enough for the client to be able to come in and create that second connection for the data object, and then close off that opening in the firewall after that connection is created. So we do that through the use of a timeout. Now we can set the timeout anywhere between 5 and 60 seconds. and generally 10 seconds is a good number for most clients. Now, we have come across some OPC clients that again, don't exactly follow the rules of the OPC and DCOM protocol spec. Some clients will do a single object request and then cache that port number that was given back to them, and then simply reconnect on that data port number anytime they need to. For those clients, you will find that your OPC connections may be blocked by the Tofino after a few hours or a couple of days. And for those clients, then you would need to check this new checkbox here labeled Never Timeout. In that case, the Tofino will leave that port open forever after it's been created by the initial object request. But we only recommend that you use this feature if you find that the client actually requires it. Okay, so here's all of our settings for that OPC connection. We have configured a firewall rule to allow the traffic. We've configured our OPC Enforcer to coexist with that OPC client that we're using. Let's go ahead and try this. We're going to change the Tofino now to test mode. We're going to give it a second to save those changes we just made. Down here you can see that there's a progress dialog. There we go, those changes have been saved. Let's change the Tofino to test mode. Now normally when we switch the Tofino from passive mode to test mode, it has no impact on the network traffic. In this case, because of the differences in the OPC protocol, our OPC Enforcer will not know which ports are being used by an existing OPC data connection. So in order to actually try our Enforcer configuration, we have to restart our OPC client after we change the Tofino to test mode. We don't need to do this when we change from test to operational mode, but we do have to do this on the first go around when we first enter test mode. So let's go and do that now. I'm going to go back to my OPC client. Let's restart our client here. All right, Matricon, Explorer. And I have saved a project file here, which I'm just going to open. Let's go back to our CMP, and there we go. We have an alarm message, a heartbeat. In this case, it's not really an alarm, it's just a notification saying, hey, I saw an OPC connection from this client on 22 to the server at 21, and I opened up the port in the firewall to let that traffic through. Here's the port number, 1088. So this is the notification from the OPC Enforcer that we did see a valid OPC connection request, and we responded to it by enabling that port in the firewall. Here's another one here. In this case, we opened a port on IP address 21 to the server on IP address 22, and the port number was 1044. So this is interesting. Why do we have two connections here? And we've got one that shows a connection from our client device at IP address 21 to the server at 22. And on this other one, we've got a connection back from the server on 22 to the client on 21. Well, this is very common in OPC systems. You'll very often find servers connecting back to the client device. So this is why we default and actually force these rules for OPC protocol to be bidirectional, because it's almost guaranteed that you're going to have to allow OPC connections in both directions for your OPC system to work. So that was easy. Let's take a look at one factor here that does come up quite frequently with OPC installations. In this OPC example, we connected from the client device to the server device, not by using the name of the server, but by using its IP address, 1.22. That's certainly a valid way to connect between OPC clients and servers. but it's very common that these connections are configured to use the OPC server computer name rather than its IP address. And if we tell our OPC client, hey, connect to OPC server.triconics or OPC server XYZ, and that's the name of the computer that we want to connect to, the OPC client must have a way of resolving that computer name down to an IP address. And this is usually done with the Windows NetBIOS protocols. So when we're putting Tofinos in front of industrial controllers, those controllers never use NetBIOS protocol. And in those cases, we can simply block the NetBIOS protocols and consider them to be more or less of a nuisance protocol that doesn't help us in that part of the network. However, when we're putting a Tofino between two Windows PCs, and specifically when it's going between an OPC client and an OPC server, very often we must allow those NetBIOS protocols to pass between at least those two Windows PCs in order for services like OPC to work properly. So how do we set that up in Tofino CMP? We have protocols available in the Tofino protocol list, and here's how we set it up. First of all, we need to allow broadcast traffic for the NetBIOS protocols to pass through the Tofino from one PC to another so that they can find each other. And then we need to allow unicast traffic to pass between our client and server for these protocols as well. Okay, so here's how we allow that traffic to pass through the Tofino. First of all, we need to create a broadcast rule for two protocols for each of our Windows PCs. Two protocols are NetBIOS Datagram Service and NetBIOS Name Service. So let's go ahead and do that. First of all, we drag our two devices to this list called Broadcast Rules, and this is on the Tofino's Firewall tab. And then we drag these protocols onto those device icons. Let's do it again for the other protocol. So we've done one set of rules for Datagram Service. Let's do another set of rules for Name Service. Alright, so this covers the case where the two PCs are broadcasting their name information and they need to be able to hear each other in those broadcasts. So that's covered. Now let's go and create the same set of rules now for unicast traffic. So here we're going to do that on the Firewall tab for the OPC server. We already have the OPC client here as a talker on this Firewall tab, so we simply need to add those protocols, and we have to make sure that they are set up for bidirectional traffic. Datagram service and name service between the OPC client and the server. So if your OPC client and server if your OPC client needs to connect to your OPC server by name, adding these firewall rules here on the OPC server firewall and over here on the Tofino's firewall tab should do the trick. One other minor complication, this setup assumes that you're using peer-to-peer networking. If you're using a domain-based system, then you'll actually have to allow rules for each of your Windows PCs to connect to your domain server. That's actually simpler because you can simply add your domain server to your network diagram and then create unicast rules from your OPC client and server machines back to that domain server. So that's a quick discussion of the Tofino OPC Enforcer module. Thanks for taking the time to join us today. I hope you found this useful. And if you have any questions or would like to know more about the Tofino Industrial Security Solution or the OPC Enforcer module, please contact your Belden Hirschman sales representative.